Okay, so welcome back. We're now going to take a look at another example here. This time we're going to use a secant substitution. So we have the integral of the square root of x squared minus 9 over x dx. So we want to work this out. Of course, unfortunately, if this was the other way around, x over the square root, we wouldn't even need a trig substitution. We could just, go through the problem. But that's not what we have. So let's start to work with what we have. We have a square root we have an x squared minus 9, right? We have x squared minus a squared. So we're dealing with that x squared minus a squared. So we do the substitution. X equals a secant theta. So 9, of course, would be 3 squared. So x is equal to secant theta. Dx then would be the derivative of secant theta, which would be 3 secant theta tangent theta. Okay. And so we go in and put in what we have and see how things are going to work out. Right? Basically see how things are going to work out. Okay. So in the integral, we'll have square root of x squared minus 9. Hold on here, I need my integral to move over a little bit here. Right. Integral. And then that's all going to be over. Okay, so x squared, so 3 secant, that all squared. So that'll be 9 secant squared theta minus 9. In the bottom, we have x, which will be 3 secant theta. And then dx is 3, I forgot my d theta there when I wrote it down earlier. 3 secant theta, tangent theta, d theta. Okay, so now we start working this out. So first things first, our secant theta and our 3, by the way, both of them, will both go away in this example. And then I have this stuff. All right, then I have this stuff. 9, square root of 9, secant squared minus 9. So let's work with that first. We'll simplify it and then put what we have left back together. So for that, I can pull out a 9. Now I have secant squared minus 1. But remember, secant squared minus 1 is tangent. Secant squared minus 1 is tangent. So this is going to be 9 tangent squared. But square root of 9 is 3. The square root of tangent here is tangent. So we're going to have 3 tangent theta. So putting it together, we're going to have 3 tangent theta. That's what this is. Times tangent theta. That means we're going to have 3 times the integral of tangent squared theta d theta. And you have 2 options here. You can refer back to the reduction formula for tangent, or what I simply remember is that secant squared minus 1 is tangent squared. So tangent squared is secant squared minus 1, and I know how to do integrals involving secant squared. So I can rewrite this as secant squared minus 1 d theta, and I can integrate both of those. Integral of secant squared is tangent. Integral of 1 d theta is just theta, but don't forget about the 3. And then we're not doing a definite integral this time, so we do include the plus c. All right, now that gets my integral worked out in terms of theta. Right, that gets my integral worked out. in terms of theta. But I need my integral back now in terms of x. So this is again where we go back to our condition. X equals 3 secant theta. Which means that secant theta is x over 3. So we have to go to the diagram and draw the picture for secant theta so that we can talk about tangent theta. 3 theta part's easy enough to do. That's going to bring in an arcsecant. That's going to bring in an arcsecant function. Okay, that's not a problem. But the tangent does introduce a problem. Okay. So when we come in here and draw our picture, secant can go in either the first or second quadrant. Remember, it's tied with cosine. It's tied together with cosine, and inverse cosine is first or second. So I'm just going to draw the picture in the first quadrant. Draw in my reference triangle, my theta. And in secant, remember, cosine is adjacent over hypotenuse. Secant, it's reciprocal. So it's going to be hypotenuse over adjacent. And then we use the Pythagorean theorem to find the third side. Third side here would be square root of x squared minus 3 squared. Or, in other words, square root of x squared minus 9. Now, there are some things we have to worry about with the x here as a function. Technically, x, when we put it in the hypotenuse, we really should throw absolute value around it since we don't really know what's going on. I don't think that's going to be an issue here as far as our answer, but it is something that we do have to be a little concerned about with the secant. What's going on there with that. So I don't think it's going to matter here, though, as we deal with 3 tangent theta. Tangent theta is opposite. That would be this square root. So I'm squaring the x. It doesn't really matter whether it's absolute value or not. So since I'm squaring it, it doesn't really matter. So it's that over the adjacent, which is 3. So that's kind of nice. It's going to be 3 times square root of x squared minus 9 over 3 and minus 3 theta, which will be 3 times the arc or inverse secant of x over 3, and then plus constant, and then simplifying here, we will have square root of x squared minus 9 minus 3 inverse secant of x over 3 plus our constant. Okay, so there we are. I'm ready to move on with that one. Okay. All right. So this was an example here that ended up involving an inverse secant. And like I said, sometimes with the inverse secant particularly, we do have to be concerned with that. If that had come about in some something that was left over, then maybe we'd be a little more worried about that absolute value on there. Like I said here, it doesn't really matter. It doesn't really matter. So we're okay with what we have here.